transportation, specifically for the case study I have chosen. Let us first get aware with the concept of multimodality. We all know that urban agglomerates and metropolises are the hub of all economic and trade activities, and what churns these cities on wheels is the urban public transit system of any city. So when we talk about public transportation system or a public transportation trip, eventually all the public transportation trips are multimodal, because when you start from your place of origin and when you go to your place of destination, you not only use one mode, but you also use other modes like walking, bicycling, to access or to get the egress towards your destination. So I would define multimodal urban public transit trip as a trip of integration of two modes of travel used for one single trip where a transfer is necessary. We would consider walking mode as one of the modes of this public transit system. Now these trips are segregated into access part, the line haul part, which is the main and primary line of transit, the egress part. Since all these trips are multimodal in nature, we have a phenomena which is taking up when we leave one of the modes to take up another. It's called as transfer mode. And when there is a transfer, it happens on separate stations, buses, stops. Together, the access stage, line haul or main mode stage, egress stage and the transfer stage comprise of the structural elements of the multimodal transportation system. The research issues we would be discussing here is in the previous researches as those of Avishai Seder, N. van Oort in Netherlands and Mr. Sabyasachi Mishra and David Henscher et al. They have evaluated various aspects of service reliability, spatial interconnectivity and efficiency of public transit modes. This research aims at developing a mechanism to evaluate performance efficiency with a perspective oriented towards the ease of travel, service reliability and operational time-related temporal parameters of the multimodal public transit systems. We venture into the scope of evaluating the efficiency of MMTS in the context of how we can make the total travel from door of origin to the door of destination more friendly to the commuter and more friendly for him to take up the decision to leave the private transport and come forward to take the public transport mode. These are the stages which are given in this illustration. We can use the access and egress modes in India like these ones. Recently, we are encouraging and coming forward for the use of quadricycles as IPT modes in the access and egress modes also. And then we have the transfer points where we can take the metro or a city like Delhi, which can be the main line haul mode, for example. We would like to define the three key measures of evaluating this multimodal efficiency, which would be proximity, connectivity, and interconnectivity. As you can see in the illustration, the proximity is the distance that you cover from the origin to the destination of the access station. Then connectivity is the main line haul, which is giving you access to various stations. And interconnectivity includes the ability to reach the desired destination from a specific origin, door to door. The performance measures are the operational temporal measures, which we should be analyzing are travel time ratio, which is the ratio of the total ratio of the travel time by public transport in a single trip conducted and to the ratio of the travel time by the personal mode such as car, walk, bicycle, etc. Then level of service as the weight of out-vehicle travel time to the in-vehicle travel time. Then interconnectivity ratio of access and egress time taken together to the total trip time. And we have passenger waiting index, which is the ratio of the mean passenger waiting time to the frequency of the transport services. These indices have their own ranges. Like for TTR, the ratio ranges from 1 to 5, for level of service from 1 to 2 to 5. For interconnectivity ratio, it falls between 0 to 1. But for most of the multimodal trips, we find it between 0.2 to 0.5. Then we have the running index, which is the ratio of total service time to the total travel time. This is the study area. We would be working on red line. We had taken a commuter survey on the stated preference data of the red line. And we can see two major interchange stations on this, which is the Kashmiri Gate and the Shahadra, where we can transfer for intercity multimodality also. The study has been divided in two parts. The first is the analysis of travel time elements, and the second is the influence of these travel time elements on the performance of the transportation system. This is the questionnaire which was aided to take up the data, including the demographic data and the travel time data of the passenger. These were the metro stations, and we analyzed them for their number of samples collected from the commuter, as well as the feeder bus availability and the minimum transfer time at these particular stations. In this illustration, we can see certain transfer areas like lifts and elevators, and also the queuing area where we see when we are getting the service for the entry and exit of security check. These areas sometimes allow the passenger to go through in 2 minutes to 5 minutes, but in crowded transfer areas it might take up to 10 minutes or more. And we have the analysis. The purpose of trips distribution is shown in the pie chart. We have 36% of office goers. And when we are talking about transfer stages, we have 2-stage, 3-stage, 4-stage, and even up to 5-stage transfers for one particular trip. The distribution of work trips is maximum in the 2-stage and the 3-stage transfers. This is a particular zone map showing the construction of zones on the red line and the catchment area in the software suite Visum. This is the demand matrix analysis in favor of the public transport done on Visum by including wait time, travel time delay as the input parameters, along with the other basic travel time information. Then this is the simulated mode share for horizon years. In 2011, the 52% share of the public transit, if we take these parameters into concern, when it is projected for 2021, according to the software suite, it gets to the maximum of 56%, and for personal modes from a 37% to 44%. So though our public transit share is increasing, but our personal mode share is also increasing. That brings us to the concern of further trying to allure the public transport sector and orient the people to try and come forward to use the multimodal transport system. These are the cumulative frequency distribution of the access time in minutes, which is amongst the non-motorized and motorized modes. It shows a trend line of a normal distribution graph, which shows that beyond a certain time, a person recedes to get access towards the public transportation. Similar is the trend with egress time. Again, I'll go to the access time. Here, the recedement of minutes would be lesser than the egress time. A person is less likely to access a public transport unit if the access time is taken more, and for the egress time it's more. Then we evaluated certain qualitative measures such as speed, cost, comfort, reliability, and ease of transfer from passengers, and got the replies where reliability was of major concern for all the commuters, and reliability always includes travel time reliability, which is hampered by travel delays, waiting time, and transfer time delays. This is the prediction of modal share. This is the indexes shown on the pie chart. The yellow part consists of 10% of total waiting time. The red pie consists of 14% of total transfer time. Together they constitute about 24% of travel penalty, which makes the commuter to go away from the public transport towards the private transport. We have an out vehicle time of 41%, 35%, and in vehicle travel time of 41%. And the conclusions include that we have chosen stated preference as our method for questioning the commuters because it's the most preferred method for displaying a new mode. And multimodal transportation is considered effective only if you are talking about access and egress on a shorter time and on long distance trips. Then we have also seen that in slow modes, particularly walking or bicycling, has a dropping and receding of passengers after a distance of 2.5 kilometers. And then they look for other modes such as LPT, bus, and two-wheelers or three-wheelers. Then we have the commuters are unwilling to use public transit after reaching a maximum threshold of access and egress. And again, then these parameters, like operational parameters as I have discussed, are the most important and complex travel time elements that are required to operationally analyze the efficiency of a multimodal transportation system. Thank you.